All right, so you've poured months, maybe even longer, into building this amazing analytics model. You're finally ready to unleash it, but then this little question starts nagging at you. It can feel like a total black box, can it? This super complex algorithm just spits out a number or a prediction, and you're just supposed to trust it? I mean, how can you really be sure it's making the right calls? How do you build that confidence, especially when it could have a huge impact on your business? Well, the answer is definitely not to just cross your fingers and hope for the best. The key, really, is to treat it just like any other business process. We have to validate its performance with a structured, measurable approach. It's time to look under the hood of that black box, and the way we do that is by grading its work. Okay, so before we can even think about improving a model or, really trusting it, we've got to measure it first. We need to get away from just guesswork and start giving our model a clear, understandable grade. This is really the foundation for building a reliable and effective analytics solution. And that, of course, brings us to the big question. So, how do we grade a model's performance? A simple pass or fail just isn't going to cut it. We need a way to see not just when it's right, but also when it's wrong, and maybe more importantly, how it's wrong. And for that, the main tool we use is something called a confusion matrix. Now I know, the name sounds a little intimidating, but its whole purpose is actually to create clarity, not confusion. Think of it as a simple but really powerful table that gives us a complete report card on our model's performance. It just lays out what it predicted versus what actually happened. Let's make this real. Imagine a logistics company builds a model to predict shipping delays. This confusion matrix right here shows us its test results on 10,000 shipments. Okay, so top left quadrant, it correctly predicted that 7,670 shipments would be on time. Great. Bottom right, it correctly predicted 1,220 would be delayed. Those are the wins, the slam dunks. But the other two boxes, that's where we see the mistakes, the false positives and the false negatives. And honestly, that's where some of the most important insights are hiding. So if you're looking for that big headline number, what is it? Well, if we just add up all the correct predictions, we see the model was right 8,890 times out of 10,000. That gives us an accuracy rate of 89%, which, sounds pretty good, but accuracy alone never, ever tells the whole story. Right, because we have to look at the other side of the coin, that 11% error rate. And this is where things get really interesting, because not all errors are the same, are they? The model incorrectly flagged 940 shipments for a delay when they were actually on time. That might cause some unnecessary shuffling around. But maybe more importantly, it completely missed the delay on 170 shipments that were late. Ouch. That could lead to some seriously unhappy customers. So understanding the business cost of each type of error, that's what truly validates a model. Okay, so the confusion matrix is fantastic for grading a model on old data. But what about in the real world? How do we validate it in a live environment before we, hand over the keys to the car? Let's talk about a couple of really practical ways to do that. There are two main methods for this. Let's start with the first one you see here, the parallel run. The idea is super simple. You run your new model right alongside your existing process. But, and this is the key part, you don't actually act on its decisions yet. You just watch. You compare its outputs to what you're already doing. This gives you a real-world test without any of the real-world risk. It's brilliant. All right, now let's talk about the second method, retrospective processing. This is kind of like a financial what-if machine for the past. You take a whole bunch of historical data, let's say all of last year's loan applications, and you run them through your new model and its decision strategy. Then you can actually calculate what the financial impact would have been. It's a super powerful way to put a dollar figure on a model's potential value before it ever goes live. So, once you've validated your model and it's up and running, the job's not over, not even close. The world changes, right? Customer behavior shifts, new data comes in, and even the absolute best models can start to lose their edge over time. So the next step is to constantly be tuning your model to keep it performing at its absolute best. So what happens when you see that 89% accuracy start to slip? Maybe it drops down to 85%, and then a few months later, it's at 80. This is a really common thing called model drift. So does that mean you have to just scrap the whole thing and start over from scratch? Well, not necessarily. This is where we really need to understand the difference between tuning and replacing. And this difference is so important. Tuning, think of it like a tune-up for your car. You're still working with the same engine, but you might adjust the input variables or tweak some performance settings to adapt to new data patterns. Replacing, on the other hand, is like getting a whole new engine. It's a much bigger job for when tuning just isn't cutting it anymore, and you need a totally new approach to solve the problem. This whole idea of constantly improving your models leads us to this really fantastic framework that the most data-driven companies use. It's a way to get beyond just putting out fires and instead build a systematic culture of innovation. It's called the champion-challenger cycle. And what this does is it turns model improvement into this continuous, never-ending loop. Your current best model that's running in production, that's your champion. But in the background, you're always developing a challenger. It could be a tuned version or a completely new model. You test them both head-to-head on live data, and if the challenger proves it's better, it gets promoted and becomes the new champion. And then guess what? The cycle starts all over again. And this really gets to the heart of the whole thing. The champion-challenger model isn't just some technical process for data scientists. It's a business philosophy. It makes sure you're never just resting on your laurels. You're always testing, you're always learning, and you are systematically guaranteeing that your best analytics are the ones driving your business forward. So, what are the big things to take away from all this? First, you just can't trust what you don't measure. Use a confusion matrix to get a clear, honest grade on your model's performance. Second, validate your model in the real world using low-risk methods like those parallel runs. And finally, don't just build it and forget it. You've got to adopt a continuous improvement cycle, something like champion-challenger, to make sure you always have the best model running. So you see, trust in your model isn't about blind faith at all. It's about building a solid system of measurement, validation, and constant improvement. If this explainer helped you out, please go ahead and like, share, and subscribe for more. And hey, the next time you're presented with a new model, remember to ask not just, is it accurate, but how do we prove it, and how can we make it even better tomorrow? Thanks for watching.